Welcome to a demonstration in chemoluminosity. That is when chemical reactions occur that give off energy, but not in the form of heat, but in the form of light. In the type of chemoluminescent reaction we have here, we will be combining hydrogen peroxide, H2O2, with phenyl oxalate ester, mixed with a fluorescent dye. The reaction produces phenol and a peroxyacid ester, which is unstable. The ester then decomposes to produce more phenol and a cyclic peroxy compound. That in turn decomposes to form simple carbon dioxide, CO2, and that is the end product. It is the energy that is released in the decomposition to CO2 that causes the electrons to jump to higher energy levels. And once they are there, they return to ground state. When they return to ground state, they release wavelengths of visible light. In other words, the transition from the excited state for the electrons down to the ground state or near ground state gives off enough energy to be equivalent to some wavelength of visible light. The actual wavelength of visible light depends on a number of things, such as the type of dye that is being excited. Hello. We are now in a dim light situation where we are actually going to show you these chemoluminescent reactions. The first one I'm going to do is with a fluorescent dye right here that is kind of an orangey color. And so that you can see this better, I'll turn the lights on. It is a slightly fluorescent orange color, but it is giving out no light. So I'm first going to pour that, I guess I'll do it second. I'm going to pour in the first solution, which is the hydrogen peroxide, and we'll pour it in a small 50 milliliter beaker. I'll place it over there. Now we're going to pour in the actual activator, and it is lit up a little bit but not a lot, so I'm going to set these aside. And I'm going to pour in two other materials. First will be the activator, putting it in a little glass cup, and then there we go, the other solution. And you can see how bright this gets, very bright. And now we'll pour in this just to add color, and we get a tremendous reaction. And the color comes out between the green and blue. This is actually a very light green, and it will last for quite a while. Let's see if we can pour it back into this cup. I think the first time it didn't light up because I may have used the wrong vial. I can't see myself in this darkness. So look at how bright that is. Tremendously bright, and it will last this way for a good hour. The electrons are falling back down to ground state, and as they do so, they're emitting visible light, and it's cool. There's no temperature. It's neither exothermic or endothermic. It's probably a little exothermic, but you can't feel it. You just can't feel it. And that's our chemoluminescent demonstration for the day.